all, and welcome to another high-powered episode of the High Voltage Live Show. I'm your host, Willie Snyder with Nat King Code, joined by the excellent and awesome creator of the High Voltage Live podcast, Mr. James Stallcup, over there in Big Twister, Texas. And he is representing the Volt Online Academy, the best education you can get online, period. And we have a great show for you guys. We're really excited. James worked his tail off, and really appreciate it, James. Looks like everyone's joining in. I just saw the viewers just start hopping in. Welcome in, sir. Awesome to have you. Thanks for joining us. And it's really awesome that we're able to put these through. And I think I opened your eyes to how these myths can get started and how many we could build up in a short amount of time, and possibly get some facts out there for everyone so that we can kind of shut down these myth factories.
Yeah, there's I get tagged on videos and stuff like that, to watch this, and
what?
I'm like, that's not right. I've never heard that before, but we're going to touch base on that. And I took and I posted some new illustrations up. I hadn't posted in a long time, and I don't think everybody reaching out. My messenger has just been blowing up. When's that going to be available? I mean, just left and right. And there's so many that are interested in the journeyman, and it is unbelievable when it comes out. And I just appreciate everybody contacting. So I decided to do a post to tell, a lot of the main features because of all this interactivity that's in it. Because I was getting bombarded, and I don't really have time to answer everybody. So I was like, I'll just do a good post, and everybody can read that post instead of just, all these messages coming in. Hopefully that answers a lot of the questions for everybody. So
yeah, I agree with that. Yeah, and it's been really awesome for me because all of a sudden, like, think of a myth, and then I'll go up to the guys at the job site, and I'll just be like, hey man, have you ever heard this before? Oh, good evening. Thank you for joining tonight. Appreciate it. And I'll just go up to these guys, and I'll say, hey, have you ever heard about this? Like a transition fitting not being permitted to be a pull point, or whatever, and just get them fired up. And these guys say, you know what, Willie, we really love the myth of the week. So I'm like, all right, well, I'll just keep bringing the heat, just keep bringing them. And, last week's one was pretty good. It was a lot of fun. And especially working in a hospital, because we are really concerned with life safety. We have a lot of med gas in there. There's a lot of different stuff that we got to worry about with the grounding and bonding. We got to really pay attention. And I learned something I didn't know about the bond bushing being required in the healthcare code.
Yeah, it's really interesting because I've been contacted. Justin Gibbs contacted me on one of them, and I was like, we got so much going on here. We're actually going to do 3 myths this week, and
nice.
I will say I'm a little pissed off about it, and it's not because I'm doing the myths. You know why? Because tonight is the NFL draft. So once this is over, I'm off of this podcast. I'm telling you right now, I'm going to watch that because Cowboys pick at 26. Represent right here. Yeah, okay. Cowboys. How about in Cowboys? Cool. America.
Yeah, you guys.
Don't know America's team.
you guys need to get like 5 quarterbacks up in there so you can not choke in the playoffs. But
they the hell did. I was upset with that. That's all right.
Yeah, it is. It is what it is.
All right, let's do. You ready to do meme of the week?
Yeah, so I wanted to tell everyone a little story about the meme of the week. So this is when your apprentice doesn't listen to you. When you tell him an easy thing to do, and he doesn't listen to you, and you're sitting there watching him sweat and just do all this stuff. This is me with my copy, just sitting there just like, dude, what are you doing? Going up and down on a lip trying to untangle 6 wires when he could have just pushed 2 of them down the conduit and been done with it. But that's what this meme's all about.
All right, let's cue it up.
And it cracks me up every time because it's like, dude, what are you doing? And then I was just like, whatever. I was like, I'm done. I don't even want to tell you no more. Whatever. Just do your thing. Then I go start doing something else. He comes over. He's like, hey, would you believe my lift is dead? I was like, well, yeah, you've been going up and down for an hour trying to untangle them wires. Not listening to me. He didn't even need to come down in the beginning. You know, why are you going up and down with your lift anyway? And this is like 40-foot ceiling. So, you know, you have to come all the way down, tangle, go all the way up, go all the way down. I'm like, dude, why don't you just push the two down and untangle them while you're up there? You don't even need to move your lift at all. And I couldn't believe it. So I had to make a meme about it, and it was pretty funny.
That's cool. I like it.
I know a lot of journeymen out there would be like, dude, that's me every day.
That's funny.
I always say they're hurting my brain. And so I say I have to get some bubble wrap, put it in my hard hat.
Yeah, I get it. I think everybody that's gone through the trade has had an experience like that. Something every apprentice has to go through it.
Yeah, we got some good apprentices out there and that want to learn and stuff. I've been trying to work with them and lay them out better and get, a little bit better communication and try to, do it right the first time. And so it's just as much a leader's fault as it is an apprentice's fault. But I just hate when apprentices don't listen. Like, I mean, some of these guys, like we had one where he's doing heat shrink on a high press, and he only put it on half the high press. So it was like you had half the high press that didn't even have no heat shrink on it. I'm like, dude, look at the way the manufacturer did it and match it. You don't put heat shrink on there to miss half the bare part, and I just like, why would you do that? You just, and I like guys will come up sometimes and they'll be like, hey, I think I messed up a heat shrink.
Yeah.
And you're like, how do you mess up a heat shrink? Like, oh, I started heating it up. It wasn't on the right spot. You're like, no, you make sure it's on the right spot when you start heating it up. It just blows me away. I try to be as patient as possible, but it is what it is. You know how it is.
Oh yeah. All right. First myth of the week. You ready?
Yes, sir. Let's do it.
It's time for Myth of the Week.
All right, so this one kind of got me fired up because, and I did tag you on this, James, because I hear a lot of people talk about this where you're running to like an AC unit, and they're like, okay, well, if you're running to the AC unit, then if you have fuse disconnect, then it becomes a feeder. Nope. And then it's not a branch circuit anymore. And so then they're saying that you have to size it differently, where you have to actually size off the main overcurrent protection device. So they're saying you have to size it off the, like, say, the circuit breaker in the panel. And well, one thing that you'll notice when you're encountering 240.4G is that you don't have to provide overload protection for that exception in 240.4G. So that's kind of why I called you in on this. I needed some backup, and I was like, yeah, James got to hear about this because this is a weird interpretation.
Yeah. Well, when I looked at this, when I first heard it, I was like, all right, I'm going to have to make a comment because I've never heard of something like that before. And if you look, we've been doing this now, this same calculation that you're looking at here. I didn't fill in the blanks or anything. I just pulled it out because it's a newer illustration for everybody to look at. But you can
I like the color on that. It's nice.
Yeah, the way that the illustrations coming out, they're unbelievable. But when you look at that, you're going to a single motor, and you'll notice I put one in here where we were going to time delay fuses. And if you look at how we're sizing the conductors right there, we're saying coming from that panel board right before that disconnect, you'll see we're sizing them by which table, which section, 430.22. Okay.
Yep, sir.
430.22 is for a single motor. Now, I put another one here for you to look at. This is one where you're looking at a feeder. Now, a feeder is where you're going to go and supply 2 or more type motors. Now, for him to say it's a feeder, I'd like to know how he figured that out, because he's basically, when I listened to this, he was twisting the definition. Now, what I want to do here before I get in and start showing this, I want to play the audio for everybody to listen to. Then I'm going to comment on this audio and why I do not agree with it.
What's a branch circuit? Well, a branch circuit is the conductors and equipment, or the conductors that begin at the last overcurrent device of the circuit and end at the outlet, at the utilization equipment, essentially. So here in this photograph, if this disconnect does not contain fuses, then that means the branch circuit started at the panel board inside, and the branch circuit extends through the disconnect to the equipment, right? Because where that liquid type flexible metal conduit meets the equipment, that is the outlet. Okay, so the switch is not the outlet. Where it ties into the utilization equipment is the outlet. Just like if you have a lighting outlet, right? Lighting outlet, the switch is not the outlet. The lighting outlet, the box in the ceiling, is the outlet. Same concept. Hardwired piece of equipment in your ceiling for the light, hardwired piece of equipment here. They both end at outlets. So the branch circuit starts at the last breaker or fuse and ends at the outlet. If this disconnect back...
Okay.
Dude,
Now,
I wanted to tell you my Ryan Jackson drinking game is every time he says outlet, you have to drink.
Oh, really? Be drinking a lot. Now, what I'm going to touch base on that outlet too. And, you know, he made a statement. He said where you had your lighting, he goes, it connects there at the outlet, the box. Yeah, like I've been trying to say for over and over, the box is the outlet. It's not the connection. That's where your outlet is. But we're going to go a little deeper in that.
Hey, is there any confusion on where the outlet is when there's an outlet box?
No, it's the outlet. It's like you have a receptacle outlet. There's a definition, and the receptacle goes in it because it's what? A device. But we're going. I'm going to touch base on that in a minute. But as you look at this right here, this illustration, you're going to see we're showing a feeder where it's going over and supplying 2 or more motors. Okay, and you'll see we tell you in order to size that overcurrent device, you'll look at 430.62A. But if I'm sizing the conductors, the feeder conductors, I'll look at what? 430.24. Okay.
Yeah, and what we could build on too, James, is I know last week when you got cut off, you were going to do sizing tap conductors.
I'm doing that tonight.
Oh, okay, cool.
I'm going to do that tonight. Now,
all right.
One of the things I want to point out here is what is happening here. He's taking definitions in Article 100 and he's twisting what the meaning of that definition is. And I'm going to prove that by looking at other text that's in the National Electrical Code that states different than what he's saying. Okay. So let's look at some text here. All right. Now, I'm just going to look here. And I want to point something out. They added a new definition in the 2023 NEC for a motor branch circuit. And it says the circuit conductors, including equipment between the motor branch circuit, short circuit, and ground fault protection device for what type of motor? Individual. Do you see that? That alone, just that definition alone, it destroys exactly where he's saying the feeder, that being a feeder. Okay.
Yeah.
But I'm going to prove this even more. Because he's going to say, well, he's going to say at the disconnect, then that's to the individual motor. Well, I'm going to prove him wrong on this point too. But there's a reason that this definition, I feel, went in is because of interpretations like what he's making. I do not agree one bit with what he's saying. I'm going to point that out right now. Now,
okay.
let's look at this right here.
I think we made that clear. No,
now, let's look here. It says, if I take and I go to a single motor, 430.22, it says conductors that supply a single motor used in continuous duty applications shall have ampacity not less than 125%. We've always sized our conductors going over there in that manner. Okay.
Yep.
But now look, if I look at 430.24, this is several motors or motors and other loads. And it talks about conductors supplying several motors or motors and other loads shall have an ampacity not less than what? 125% of the largest. Then we add all the rest together. We still agree with that, correct?
Oh, yeah.
Right. Now, watch this. Now we're going to look at this overcurrent device, and let's see what it says. If I look at 430.22, it says, I'm sorry, this is supposed to actually be, I didn't change out to 430.62 up top. That should be 430.62. But when you can see it there, I just didn't delete that first line up there. I was doing this.
The haters are gonna destroy us over that.
You know, I was working on this like at 3 and 4 in the morning last night, trying to get all this together. Now, if you look at 430.62A, it talks about a specific load, and what does it say? A feeder supplying a fixed motor load or loads consistent of conductor sizes in accordance with which section? 430.24. And then if you go down and look at the second paragraph, it says, where the same rating or setting of the branch circuit, short circuit, and ground fault protective device is used on what? 2 or more motors on the branch circuit supplied by what? The feeder.
Yeah.
See? That tells me right there, you got 2 or more. That pertains to several motors. That's what a feeder goes to, not a branch circuit. A branch circuit goes to an individual. So if I'm going to an individual motor, how can that be a feeder at that one disconnect?
Well, then you make a good point. Like if you come from an MCC, a lot of times the MCC's got fuses in them. Mm-hmm. So then you got feeder to MCC, then you have fuses, then you go out to your motor. And a lot of times you hit a motor starter, and then you go from the motor starter to the motor or for the freak drive or whatever it may be. A lot of times they fuse ahead of the freak drive. So, you know, to me, that's all branch circuit from the MCC to the freak drive.
Sure, if it's a single motor you're going to. And that's
they never do that. Like when all the stuff that I do, every single thing's an individual branch circuit. Like they don't supply motors. Typically we don't have multiple motors on individual branch circuit. Like it's not been uncommon, but like if there's 2, like let's just say you have an intake and an exhaust, then yeah, they might want them to be on the same branch circuit. That way, if one trips, they both trip. Or there's certain times where that's an engineering design application where it makes sense to put them both on the same branch circuit.
Sure. And let's just hypothetically say you go to a motor and then you add a hermetic refrigerant type motor compressor on there. That's a feeder going over there to it. You see what I'm saying? If I go to a single one over to an AC unit and I put them there, that's a single branch circuit going over. That's not a feeder going over there. And just looking at this section alone tells you what he's saying is not true.
And it's interesting too, because like if let's just say you design the whole thing to have a pull out, that's usually what we have on our job sites when we're doing like multifamily. Because we just do like a 60 amp pull out disconnect, and then if it's 30, we're covered. If it's 40, we're covered. Whatever.
It's just disconnecting means at that point.
It's just whatever. But then all of a sudden you're gonna say that they spec out fuses, and you got to change all your feeder. You're saying it's a feeder. It's got to be sized to the overcurrent protection device. That's not even right.
No, it's not. And that's what I'm saying. I'm sitting here looking at this, and I'm just looking at other sections in the code that do not agree with what he's saying.
I agree.
I do not agree with that substantiation. And I think what has happened over time, I've noticed a lot of stuff that we've had miss on is people twisting what the definition is meant for. And if you go back and you actually look when some of those definitions were put in, you'll start to get a much clearer understanding and seeing what the substantiation was from the code making panel before you start making such type statements.
And keep in mind that we're an evolving trade. We're an evolving industry. We're getting newer technologies. We're getting stuff. I went and I know we talked about this a whole bunch of times, but you try to put like a motor and a control circuit on a Class A device, it's gonna trip every time. It's the thing is making that motor work and work efficiently. To me, you have to weigh that whole, I guess you would call it a narrative. But to me, I would want to say that me and you have always promoted electrical safety. Since we've done this podcast, we've always really wanted electrical safety. We've did the Live Dead Live. You could look back. We might want to get that one set up as for like our 70E, for like our Live Dead Live test. I've explained it to guys. I'm like, if you do that Live Dead Live test, that's really important for electrical safety. And then, my whole argument with some of this stuff, these guys are kind of promoting this false sense of electrical safety, saying, well, we do this and we promote this and da-da-da-da-da. And that's awesome. I like it, but it's over the top. And when the equipment doesn't work, you decrease electrical safety. And that's kind of been my point the whole time. And I think a lot of people have taken me wrong, where thinking, oh, Bill's against GFCIs. No, I'm not. I'm not against GFCIs. I think GFCIs are a great idea. But if they cause the equipment to not work and you lose 10,000 pounds of fish and a whole village starves because of it, then that might not be a good idea. We might want to rethink that.
Yeah. So, and I'll tell you another thing I have a problem with is you try to push something, GFCI, into something, and you didn't have the technical substantiation or merit to do so. That I've got a problem with also, and I'm going to prove that here in just a minute. But I'm going to take, and I want to go over this next portion of the video, and I'm going to explain this a little more in detail because it ties in with something that was said in the first little audio. So let me play it.
A second. So just know this. Before you get too excited about air conditioners, there is a tentative amendment that says, look, we know that air conditioners are connected at an outlet point, but we're going to remove the GFCI requirements for them temporarily. So let's keep on going and we'll get there.
Okay, first of all, I'm just going to say this. There's nothing there that says there is an outlet. That's his opinion. Okay?
Yeah.
I don't agree with that either. And I'm going to show you, and I'm going to explain why I do not agree with this. Okay? And, every time I go through something, I go through and show you all the different sections and stuff, why I believe what I believe. I don't take just a definition and then take that definition and say, that's it. There's other stuff in the code that's going to apply in this case. Now,
well, kind of my opinion on this whole thing is the fact that they were like, oh, okay, well, we know, everyone knows it connects to an outlet. And I'm like, okay, where is it?
Yeah.
Oh, well, you heard in that previous audio that Mr. Jackson claims it's at the seal tight where the seal tight enters the equipment. I disagree with that. The outlets don't just float in midair. you know, so
you're
that's
using my
been,
terminology now. It's a
yeah, but
motor.
no, it's been my opinion the whole time when they said this applies to AC units, and they're like, oh, it's connected to an outlet. It has to connect to an outlet. You're like, okay, where is it? And they're like, oh, right at that seal tight. And you're like, that's the wiring method. They're like, oh, no, right at that disconnect, right where it leaves the disconnect. And I'm like, no, that's freaking device. And they're like, oh, no, right at that equipment terminals. And I'm like, no, that's the freaking utilization equipment. That's not even covered by the NEC. So I agree with you.
And this is what happened in the 2023 NEC. And they basically put back exception number 2. And they
this was actually the 2020, wasn't it? I mean, it was originally the 2020, but this is what happened in the 2020.
Yeah. So they come in, and I want to point something out before I get into this. You know, if you go look at the 2023 NEC and you go look at the substantiations from the code-making panel, I found it very interesting. If you go look at 210.8D, the code-making panel was very specific that applied to cord and plug connected and hardwired equipment. They were very specific, had a substantiation, it all applied and all this. But when you got to 210.8F, they didn't make no mentions of that.
Oh, you remember the one thing about 210.8D2? It says regardless of vintage.
That's right. They were so specific on everything. But when we get out here on the outdoor outlets, oh, we're not going to discuss hardwired and cord plug connected. They just left it open. And then you had some of them come say it applies to everything outside. I don't agree with that. And so what happened was, and I'm going to show this, the code-making panel rejected. Now, I want everybody to listen to what actually took place. They rejected, they had a task group put in place to take and write something for 210.8F. They worked on it since 2020. They did all this testing on all these different type of AC units that were, they did it in Houston. And the code-making panel by one vote voted that it lacked technical merit and voted it down. Then all of a sudden, I started hearing from all these people that are for this and saying, see, you don't know what you're talking about. The code-making panel rejected it and blah, blah, blah. And I said, the code-making panel's wrong. I said, the people that voted that should be ashamed of themselves. And I meant it, and I still meant it today. Well, then what they did, they wrote their own TIA, and then it went before the floor, and then Ryan Jackson gets up there, and then somebody posts.
Not the mic drop. Don't do the mic drop.
Yeah. And somebody posted Ryan Jackson with the mic drop. Okay. and I'm like, okay, all right. I just left it that, and they were texting me, telling me blah blah blah. It passed on the floor and stuff, and I said, and you'll back this up. I said, wait till it gets to the Standards Council. I said, because what they're doing is wrong. And I said, I don't care what anybody says. Well, guess what happened? It went before the Standards Council, and the Standards Council rejected what the code-making panel 2 did with that TIA, and actually said that TIA that they wrote and passed lacked technical merit. And they said what the task group did actually had technical merit. And then they put this exception 2 in there. And then even the AC manufacturers come back and said, you know what? We wanted to try to work with it to make this happen, but we can't do it. So I can tell you, even in 2026, it ain't going to happen. Okay. But I'm going to take it a little bit further here, and I'm going to show some of the stuff that took place here.
Yeah, that's a good point. You know, I mean, if you're going to sit there and say all RTUs are outlets, then, you know what I mean, you're going to have to say everything hardwired is. It's a little bit of a stretch.
Now, this is something you brought up just a second ago, Bill. And if you go look at Article 100 and you pick up outlet, it says a point on the wiring system at which current is taken to supply utilization equipment. Okay, where is that point? All right. Mm-hmm. Now, if you say it's the disconnecting means, I'm going to disagree, because if you go look at What a disconnecting means is it says it's a device or group of devices, and you go look at a device. Heck, you could say that it was a receptacle, the switch, the circuit breaker. Well, I just heard Ryan say it wasn't at the switch. Didn't you hear that? For the lighting? So apparently he doesn't consider that to be an outlet. And then he says, he goes, well, the point at which where it's taken is where it connects the wiring method at the utilization equipment. So you're going to tell me that outlet is just free floating there? That's your location. I've never heard that before. That's something I definitely don't agree with. But the NFPA expanded content states the term outlet is frequently misused to refer to receptacles. Well, why is that? Because there's a definition for receptacle outlet that's at the bottom of this slide. It says an outlet where one or more receptacles are installed, which is what? The box, which is what I've been saying. Then it says, although receptacle outlets are outlets, not all outlets are receptacle outlets. Other common examples of outlets include what? An appliance outlet. Okay, well, where is that appliance outlet?
Yep. Oh, welcome in, Ruben. Awesome to have you, sir.
Yeah, a switch isn't an outlet. I agree with that. Okay, and then it says include appliance outlets, lighting outlets, and smoke alarm outlets. Okay, well, let's look at that. If I have a lighting outlet, where is the outlet at? At the box. If I have a smoke alarm outlet, where's it at? The box. Okay, now I've got an appliance outlet. I guess if I'm cord and plug connecting something, that's outlet. But you're going to tell me I hardwire the lighting outlet and the smoke alarm outlet there at the box, and that's my outlet. But if I go to an AC unit, which is an appliance, all of a sudden it just free floats there at the end of the wiring method.
Yeah, and I have an interesting take on this one too. When you come into the whole thing, and we've talked about this before, because I've asked these guys, a lot of these guys that are making these claims, I was like, what's on the end of a window unit? Is that a GFCI? Is that a Class A device? They're all, yeah, that's a Class A GFCI. No, it's GFPE.
GFPE. And you remember,
and
I brought that up
a
long time ago.
It's inside a hotel with guests.
Yeah.
You know, and they're sitting there like, no, but your box that's outside next to your house has to have Class A protection because of one freak incident in 2004. And if you go to our NEC for Dummies group, go in the announcements, we have the whole story posted up there. It tells everything about it, tells exactly what happened, about how the first responders reacted, and exactly how the unit was wired. Everything's described in there. They don't want you to hear that.
They don't. Now, watch this. I'm going to show something else here. Now, if you come over and you look at a branch circuit, okay, this is the circuit conductors between the final overcurrent device protecting the circuit and the outlet or outlets, okay?
Yeah.
Now, I've heard this argument. They say, well, them other definitions below apply, but they apply to what is considered a branch circuit. Therefore, there's always an outlet. No, that isn't true. Okay. Yep. And I'm going to explain why. And if you watch this, you're going to understand why I argue this point. If I go to an appliance branch circuit, it says,
and Ruben makes a good point that a lot of people do think that the 30 milliamp is Class A, and that is a common misconception.
It is not.
It's just a common misconception that people think that you could throw a 30 milliamp device on it and comply with 210.8, the language of 210.8. But Ruben, that's the reason that we're kind of doing this, because we think that hardwired utilization equipment, if they really wanted it to be GFCI protected, they should have put it on a 30 milliamp protection device, because what will happen is, like in this case of this young gentleman who got fatally killed by a miswired unit, if that would have been on a 30 milliamp protection device, then the equipment, the minute that the child jumped on the unit, then that would have interrupted the device and it would have saved his life. So
Sure.
the Class A protection is really what we're arguing on this a lot.
Right.
The 30 milliamp would have saved his life. The 5 milliamp is irrelevant.
Right. Now, if you look at an appliance branch circuit, it says a branch circuit that supplies energy to one or more outlets to which appliances are to be connected and that has no permanently connected luminaires that are not part of the appliance. Now, what I'm going to contend here, this is where your cord and plug connecting stuff. This isn't for hardwired. That's not what an appliance branch circuit is. If you look down at an individual branch circuit, that's where I'm supplying one branch circuit to one what? Piece of utilization equipment. And the utilization equipment that's going out there is the AC unit. Okay?
Yep.
That's where I take it. And if you pay attention, if I go to general purpose branch circuit, what does it say? A branch circuit that supplies two or more receptacles or outlets for lighting or appliance. Now, this is very interesting because the first three definitions are all talking about outlets. But when I get to an individual branch circuit, there's no outlet there. It just says what? Utilization equipment.
Yep. And I think you had a good point about 210.8D where it said it is sometimes hardwired to outlets.
Yeah. I brought all that up and I asked because they were casing me and I said, well, explain to me why they say sometimes. And nobody answered. They went completely quiet like that. That statement never happened.
Yeah.
So
because they're sometimes cord and plug connected.
Right. Now, what I want to finish this up with, I want everybody to see this. This is from the Standards Council. This is what took place. Now, we heard over and over about this outlet, blah, 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 and the AC unit had to have GFCI protection. They lacked technical merit. And actually, it was the TIA that Code-Making Panel 2 wrote that lacked technical merit, and I'm going to prove it right here. It says, in reviewing the full record, the appellants renewed some of the concerns counsel has heard in the prior appeal, including the practical impact of yet unresolved interoperability issues between GFCI and HVAC equipment. Additionally, the ballots on TIA numbers 1653 and 1654 reflect that Code-Making Panel 2 agreed that emergency nature is met. However, each ballot failed on technical merit by a single vote, just like I was saying. It failed on single vote. This was certain members of Code-Making Panel 2 voting this down. All right. Then it says, the council found that the task group accomplished its charge, which was to bring diverse and materially affected interests together to seek resolution of the technical concerns presented in the appeal on a narrow issue within Code-Making Panel 2's scope. In the present case of dueling TIAs, in the light of the task group's work, the council found that the task group's TIAs to reflect the closest point of agreement to address this controversial matter. Now look at that.
Right.
They basically just told you the TIA that was written by Code-Making Panel 2 actually lacked technical substantiation, and what was written by the task group that was formed to take a look at this, they voted down and said it lacked technical information. Now, this is not something I'm just making up here. I'm telling you exactly what happened. And then it says the appellants raised the concern that as of the date of the hearing, there was no HVAC industry representative on Code-Making Panel 2, but simultaneously acknowledged the difficulty to find interested parties to participate given the broad scope of Code-Making Panel 2. That said, the council recognized that by expanding GFCI protection requirements, Article 210 now impacts parties such as the HVAC industry in many ways. The council agreed with the appellant that it is therefore important to expand Code-Making Panel 2 membership to add additional parties, just not one. There's going to be more people added to this Code-Making panel who may now be directly impacted by Article 210. Well, who's somebody else that could be impacted? maybe the electrical vehicle service equipment people.
Yeah, you know how they're not even mentioned?
Mm-hmm.
Because you know why? Because the only thing that Code Making Panel 12 says you have to do is protect the receptacles.
Sure.
They don't say if it's hardwired, they don't mention that you have to GFCI protect that.
Yeah, the council, in my opinion, the Standards Council is taking a preemptive stance on this right now. And then they say the council encourages the participants and other members of the HVAC industry to apply for membership on Code Making Panel 2. Also, council directs NFPA staff to call for additional members to Code Making Panel 2 and other interest classifications as well. So there's a call for all kinds of new members on here. Code Making Panel 2 is about to change.
Dude, I don't think they're going to get that one vote this time.
No, they're not. And then it says, and I think it's going to be a little worse than that, because I think people are starting to hear the arguments behind this and what's taking place. And that's why I say the statement that Ryan made earlier that, oh, it's in the process and in the works. No, it isn't. He's making false statements. I don't care what he says. And then,
well, I could tell you what right now from the state of Colorado, I really highly doubt we're going to adopt 210.8E, which basically says if it's a service receptacle, it has to be GFCI protected regardless of the location. I don't think that's going to be adopted. And 210.8F, where it basically just says whatever we want to say is an outlet, and you have to GFCI protect it. And to me, where I disagree with it is the Class A protection, because the minute that you hardwire it, the reason that you hardwire it is you're trying to eliminate that human interaction. You know, Code Making Panel 2, certain members have been quoted saying that you don't remove the hazard. If you hardwire it, you don't remove the hazard. Yeah, that's fine. You can say that. Technically, yes, you don't remove the hazard, but you do remove the human interaction. That's the whole point of Class A GFCI protection, is to try to eliminate the human interaction from electrical shock and electrical death. That's one of the things I think is funny about that Chat GTP. If you go ask Chat GTP, what is the purpose of GFCI protection? They say to eliminate electrical shock. You're not going to eliminate electrical shock with Class A GFCI protection. You're going to still have electrical shock. You're just not going to have electrical death.
That's right.
So that's where a common misconception is.
Yeah, and then if you look at what's that say? Great phrase says, "Get on command." Get in. Yeah, yeah, true. Now, the third paragraph says the council has reviewed the entire record concerning this matter and has considered all the arguments put forth in this appeal. In the view of the council, this appeal does present a clear and substantial basis upon which to overturn the results yielded by the NFPA standards development process. Now, what that means is at the time they were adopting the code, all these people attend, hundreds of people on the floor, and then they vote to pass anything that was voted on. So basically they're saying that's when Ryan apparently did his mic drop. And now they're saying the results that were yielded by that, we're overturning that, is what they're saying. And they say,
oh, no mic drop.
Yeah. Then it says, accordingly, the council has voted to uphold the appeal. The effect of this action is that NFPA 70, the National Electrical Code 2020 and 23 editions, will include the text of TIA numbers 16, 53, and 64 rather than the TIAs that were submitted and done by Code Making Panel 2, numbers 16, 56, and 57. Now, right below
we already covered that. We already covered that too in another one, but I think that's way more in detail, and I think there's some things you missed in the last one that I think you covered in this one. It was really awesome.
Yeah. Now, right below that, there's a print 3 there, and it says, although Code Making Panel 2 did not, I can't read it with that on there.
Oh, sorry.
It says, although co-making panel 2 did not have representation on the HVAC industry at the time of processing the TIAs at issue, nor at the time of the hearing, and the application was pending for council action at the August meeting. As part of the membership actions of the council during the August meeting, the individual representing a single HVAC manufacturer was appointed to co-making panel 2. They've already appointed one of the AC manufacturers on there.
Wow.
Mm-hmm. Now, I don't care what anybody says. This here is a referendum on what co-making panel 2 did. That's my opinion on this. And I think there's more that are going to be on this panel. There's going to be some changes taking place.
So my opinion is co-making panel 2 took the side of arrogance. Do what we say, or we're going to delete, or, just basically like, you have to do it this way. Well, now we have, places where I'm at. I'm in Colorado, if anybody doesn't know. And Colorado is having a hard time with this. Colorado doesn't just typically not adopt code references. Mm-hmm. But we're getting to the point where we're like, what do we do here? We're in a tough situation. We have entire building communities that are like, hey, what's the cost of an outlet? What? Like, you're going to just make up, like, you're talking a difference of $10 to $500 on just saying it's an outlet. That's right. And it's just like, this is an outlet, and shut up. And so, Ruben, appreciate you joining us, sir, and you've had some great insight. The Tesla charger thing we've actually covered before, and I agree with you.
What he's saying is exactly correct.
Yeah, I agree.
That's exactly correct. And like he's saying there, where it plugs into what? An outlet. That's what, been my whole argument the whole time. And I think the definitions and everything are clear on that. I don't think there's any misinterpretation at all. But
so just so you know, Ruben, the guys like Ryan Jackson out there are saying that EBSE is hardwired to an outlet, and that you have to have Class A protection for the outlet, even though the Tesla charger says, do not put this on GFCI, because if it's hardwired, GFCI protection is not required. These guys are trying to go above and beyond the listed and labeled equipment and say, oh, yeah, no, you still need to have Class A protection, because me and James just, like, we shake our heads when we hear this stuff when they start talking about it. But they actually said the listed and labeled instructions, even though it says personnel protection is provided with that piece of equipment from the manufacturer that complies with co-making panel 12, you still need to go off co-making panel 2 and put Class A protection ahead of that device, even though they tell you not to. And then they're even saying you can't install that piece of equipment in the outdoor because it goes against co-making panel 2. Mm-hmm. So
I would ask this, everybody that's on the podcast.
Yeah, Ruben, I do think that GFCI's work in series. The problem is that the EBSE is it's a different class protection. So it's not a Class A protection. So Class A protected devices are not compatible with everything. GFPE has been known to have a leakage current of about 20 milliamps. Mm-hmm. And so we're in that gray area. And co-making panel 2 says, do not install any equipment that has a leakage current above 4 to 6 milliamps. So then what we have to do as electricians is we have to, kind of just tell co-making panel 2, hey, is that a rabbit? And then we have to go just put it in, because the equipment says that 20 milliamps of protection, of personnel protection, is compliant for their equipment. So who is co-making panel 2 to come in and say that's not going to save a life or whatever, when they have no idea that this is a listed, labeled equipment that has been evaluated by a testing agency, mm-hmm. and proven to be adequate for personnel protection. who are they to sit there and say that 20 milliamps of GFCI protection or GFPE, whatever it's called, is not adequate for their equipment? Who is code making panel 2 to say that? It's just wrong.
I agree. And I'll say this, I usually don't say anything like this, but people are watching podcasts. I would ask, share this podcast, because there's a lot of information here people need to be aware of. This is something that needs to get out there and people to see what is taking place. Now, I've got one more myth here. This is courtesy of Justin Gibbs. And he had contacted me. This was dealing with the application of 230.82 and 230.85. And what this got into was on the supply side. And what we were dealing with here, he was asking me, is where they I take and I have a Generac system that's set up at a house, for instance, and then I've got the Generac generator sitting out there on the pad on the ground, and then I've got my ATS, my automatic transfer switch, up here mounted on the wall. And then right before it, if you go look at 230.85, I take and I have emergency disconnect out there. Okay, now this is where it gets interesting, because I'm going to show something here and I'll end up coming back to it, but we have some good illustrations on this particular point. Hold on a minute.
I just kind of want to interrupt you a little bit, James. Apologize about this, but just to let everyone know, you could always go to last week's show. This was the question that Justin Gibbs asked. I was kind of fielding it a little bit. We had David Englehart on too last week, and we were kind of going back and forth. And David Englehart appreciated having his insight on it, and Justin Gibbs having his insight on it. But this is actually James's answer to. I couldn't really directly answer the question, but I appreciate you answering it, James. So I just want to give context on that.
Sure. Now, what we did here, we have two different illustrations, and it depends on if it's considered a separately derived system or non-separately derived system. So the second one, you'll see where we're coming in and we look at 250.35 A and B, and this is where we get in and we talk about permanently installed generators. But the point I'm going to point out here is right up above the main portion of the illustration. You're going to see we show two different types of terminations within the automatic transfer switch, and whether or not it's classified as separately derived or not. And what we're telling you here is, if you take and switch the neutral, it's separately derived. If you're not switching the neutral, then it's not considered separately derived system. Now, those are the 2 points I just wanted to point out. And what is interesting about this, we actually have in our generator transform motor compressor book, in the generator book, we show you this basic stuff here, but we also get down into this where we start showing where you have an emergency system, a legally required standby system, and an optional standby system, and how you go about setting all that up, because there's all kinds of different ways depending on how you're coming into the service. Okay. Now, as you come back and you look at this, let me get back here.
Yeah, and one thing I wanted to say too, James, is that illustration that was on your left was what was Justin was talking about, which was like a 3-wire service entrance.
Sure.
So just for context.
Sure, we talked about all that.
Yeah,
I think Justin and I have talked for about 2 hours on this. So
yeah, he'll be jumping in here. He's coming in.
Yeah.
Mark's in here. Welcome in, Mark. Appreciate you coming
brother.
in.
Now, what this comes down to is when you look at 230.82, we talk about equipment connected on the supply side of the service disconnect. Okay, that's what we want to discuss here. If you're on the supply side, all of these items here, I'm not going to go through every one of these, but this is what they're talking about can connect on that supply side. And as you'll see, it goes to where you got 12 different things here you can look at. Okay. Now, the one I'm going to point out is I'm going to look at number 10 here, and it says emergency disconnects in accordance with 230.85 B2 and B3 if all metal housings and enclosures are grounded in accordance with Part 7 and bonded in accordance with Part 5 of Article 250. I'm going to discuss that here in just a second. Now, as you take and you look at 230.85, that's where I pick up my emergency disconnects, and this is going to deal for 1 and 2 family dwellings. And if you look at B3, it comes in and we'll look at B2 and B3, but it says each disconnect shall be one of the following. You got your service disconnect, and then you have a meter disconnect integral to the meter housing, and then you have another one, other listed disconnect switch or circuit breaker that is marked suitable for use as service equipment, but not marked as suitable only for use as service equipment installed on the supply side of each service disconnect. All right?
Right.
Now, this is what I'm going to tell you here. Now, if I take and I have my emergency disconnect there at that dwelling, what you have to establish at this point, does the disconnect have overcurrent protection that's been established at that disconnect or not? Now, if I just have a disconnect, all it is, it's nothing more than a disconnect, and it's on the supply side, period. Right. And then I can take that neutral, and that neutral can be used to bond everything in, okay?
Right.
But if I establish overcurrent protection there, I will contend that is your first point of disconnection for that building. Okay.
Well, yeah. And usually what we have to do, like here in Colorado, our emergency disconnect is an overcurrent protection device. So like if I'm doing a service entrance, and I know Justin was the one that posed this last week, that it was a 200 amp. So here in Colorado, what we do just to save money or just to be, give the customer excellent value. Some people call it hack, but I always like to provide the customer excellent value. And what I like to do is I like to have our service entrance come in, hit a 200 amp disconnect or a 200 amp main breaker. And, like that's fine. But then what you would have to do in that case, and this is maybe just my opinion and not actual code, which is I didn't want to really jump in last week because I was like, there's so many things going through my head. But you might have to modify that service entrance and put a fuse disconnect and then go over to your transfer switch and then come back to your service entrance point. So it was just really hard for me to comprehend in my head. And Mark Candel's had a really good point that on your transfer switch, it's marked line load. Mm-hmm. So if you're coming in at the service entrance and you're coming in to say a 200 amp breaker, how are you gonna load side that to that transfer switch?
That's right.
So it kind of was spinning around in my head a little bit, and that's why I was like, I got to get James here because James got to explain this better.
Yeah, and if you look at that B3, it says other listed disconnect switch or circuit breaker that is marked suitable for use as service equipment, but not marked as suitable only for use as service equipment installed on the supply side of each service disconnect. Okay. Now, the way I've always looked at this is if I look at an emergency disconnect and I take and I establish overcurrent protection there, that becomes my first point. And if that's the case, that's where I establish my grounding electrode system. And then from that point going in, that neutral has to be isolated at that point. Okay. And that's where this gets into it. Now, some may look at this and say, wait a minute, I can take and just put a disconnect out there and with that overcurrent protection device. And some have said, well, I can take and come there and I can establish a grounding electrode system. And then I can come over here at the panel board and establish the grounding electrode system too. I would say that's where you get into a little problem when you look at 250.6 and you get into objectional current through the system.
Yeah,
So I wouldn't agree with that either.
I want to say this is Justin probably, but I don't know because it just says Facebook user. But since the presence of the overcurrent protection is irrelevant, 230.85B3 allows the circuit breaker to be marked per 230.85E3 as emergency disconnect and not service disconnect. But the whole thing is there, in my opinion, is now you're going to the line side of the ATS, which is service rated, on the load side, and that's not. And James was always saying that's supply side still, but to me, it's just weird because how can I sit there and say that ATS is still supply side when it's on the load side of emergency disconnect? That could be a circuit breaker that's main lug only.
Yeah, well, I look at it, first of all, you're not going to create two different grounding electrode systems. I'm just going to nix that right now. I don't agree with
I agree.
Now, if you take, are you going to take and put an overcurrent protection device out there? And if you take and put that overcurrent protection device out there, you're not going to take and ground at that spot. You're just going to have overcurrent protection with a disconnect. You see what I'm saying?
Yeah, well, it's your first means regardless.
Right. And I've always, as long as I've been doing this, I look at it from other installations. If I take, and let's just say I have a mobile home and I go out there, I've got a disconnect out there. Okay. It's a fusible type disconnect. Is that my first means of disconnection for that mobile home? Sure it is.
Yeah.
And then I run a neutral in there, and that neutral's what? Isolated.
Bonded.
Okay. So you're isolated. From that point, you do not take the neutral and use it as an equipment ground because you've already established a point. I'll give another example. Let's say I look at 250.32B and I go over to another building or structure. If I go to that other building or structure, can I take that neutral over there? You could on an existing installation, but new installations, 250.32B1 says if I go over there, I have to take and establish a grounding electrode system at that other building or structure, but the neutral has to be what? Isolated. Okay?
Yeah.
Now,
so the one that I wanted to cover with Justin, which I thought was pretty awesome, and Justin was he kind of reached out to me on this originally, and what basically I came up with is like, so you have that transfer switch. It says, I think it's in 250.24, I want to say, but don't quote me on that. Is basically that you can have a supplemental ground electrode to your additional equipment. Like, so he was saying, do you have to modify that? So in that case, what I would say is you still leave that as your first point of disconnect, and then you just run a supplemental electrode for your bonding of your transfer equipment.
mm-hmm.
And I think that's allowed per 250.24. I believe it was 250.24.
Well, what I would ask here is I'd look at this from another point too. Let's hypothetically say that was not.
Justin's fired up.
I know what he's saying, and what I'm saying is once you establish that first point there, it's telling me that I can have that emergency disconnect marked as suitable for what? For use of service equipment. That's my service equipment at that point. So therefore, 250.24 would apply. But let's just look at it from one other point.
We got the Okie from Muskogee.
Hey, Andrew.
Shows.
Yeah. Now let me give you another example. Let's hypothetically just make another point to this. Let's say that it's not a separate drive system; it's a non-separate drive system. Okay. Now, if you come back, and I'm going to show you something here. Let me go back to this slide here. Now, if you look up there and you look at that transfer switch there, and and I go to a non-separated drive system. Look at my setup now to the way that I'm connecting that. I'm actually using the neutral to do what? Connect through the system. But if I go back over here to a separate drive system, the neutral's being switched. Well, if it's being switched, how am I grounding at that transfer switch?
It's got to be ahead of it.
Yeah, that's what I'm saying. You've got to look at other installations that could affect the way that you set that system up. And that's
it's regardless whether it's 3-wire or 4-wire, that don't matter.
Yeah. Now, if you look, this is interesting because if I go look at 250.35, it gives you the options here where you talk about a separate drive system and a non-separate drive system. And it talks about how you go about looking at classifying a separate drive system for 250.30. But if I have a non-separate drive system, looky there, then they start telling you how to size a conductor and using 250.102C. Well, why is that? You see, when you get in and you start looking at it and you start looking at other sections, this can cause a problem. And personally, I see what Justin's saying. There's a problem in the language, in my opinion, because I've always been taught once you establish that overcurrent protection for that building, that's your first point of disconnection.
Yeah, and that was kind of my reluctance with the whole argument with Justin is that I think it was whatever the one that Justin was talking about, it was covering the supply side of the equipment. And so once it kind of causes problems because like you're like, oh, okay, it has to be a service rated transfer switch. Okay, well, it's service rated, but it's not technically on the supply side. Your emergency disconnects on the supply side.
Well, now, if you don't have overcurrent protection, all of that is considered on the supply side. And that's what I'm saying. Right. You have to establish where the supply side is, and that's what, Justin and I were talking about. I feel that once you establish that overcurrent protection, that's your first disconnecting, means everything on that is load side at that point. But if there's no overcurrent protection, that's at the source equipment. Now everything is considered on the supply side.
Yeah. So Andrew, basically in the 2020, I don't know what code cycle you're on, Andrew, but in the 2020, they require you to have an emergency disconnect. And it's just basically has to be labeled, located outside. It's kind of weird, but yeah, and yeah, Justin was talking about 230/85. So yeah, and I guess Justin's throwing that out there that maybe we need to say, hey, Justin, I look forward to your public comment.
No, I actually agree with what Justin's saying. Yeah, and I've listened to exactly all his comments, that we went back and forth on. But I always try to take things in a simplified manner. And I look at if you don't have that overcurrent protection, then everything's on the supply side. 230.82 applies and 230.85. But as soon as you establish overcurrent protection for that building, I was always taught that is your first point of disconnection. Just like if I went to a mobile home or I was going to another building or structure, there was something upstream that took care of that.
Oh man, he's famous tonight for sure.
Famous. Oh, I understand what he's saying, but
yeah. And Andrew,
I'll give you one more example. Let's say that you have overcurrent protection up ahead and you're going to ground the system at that point. If I go look at table 250.122, in order for me to have an equipment grounding conductor in the system, what do I have to have upstream? an overcurrent device.
Yeah.
You see what I'm saying?
Mm-hmm.
And that's what I'm thinking when I look at this. I'm thinking I have overcurrent protection upstream. The code starts taking over once you have that point there. And
Right.
if I think either they need to look at 230.85 and they need to put an information on there, and it specifically states if I have a circuit breaker in there, I've established overcurrent protection. I don't need any type of grounding system. I want to see them say that.
Yeah.
I don't think
And
they'll say that.
just to do a little shout out to Andrew, we accept all code cycles on our show. We're in 2020 here. Here in a few months, we're going to be on 2023. There's some we might adopt, some we might not, but it's just awesome to have all you guys in the house, and I really appreciate having this argument, especially with James here. I was having a hard time. I was trying to do the best I could to argue it and just get kind of James's take on it. James is way better at arguing this, and like
I'll tell you, I know what he's asking here. The problem that's happening right here is emergency disconnect and whether it has overcurrent protection or not. 230.82 is perfectly fine. All that equipment is considered supply side. 230.82, 1 through 12. All that's fine until you start looking at that emergency disconnect, and that starts to cause a problem. And my whole argument is I wouldn't put overcurrent protection there. I would just take and have a disconnect. It's just because if you look at it, what is it? It's nothing more than a disconnecting means for the building. Why do you need overcurrent protection? That's my argument right there. And I will still always maintain if I establish overcurrent protection, that's your first point of disconnecting.
Yeah, and that's a good point too, that the service point is a service point. Like, who cares if it's emergency disconnect or not, as long as it's labeled.
Sure. Let's just say that I put a mobile home. I've got a disconnecting means out there, and then I come into the mobile home, but I didn't provide any overcurrent protection or anything. Does the neutral have to be isolated at that point? No, because there's no reference point. You see what I'm saying?
Yeah, I mean, you could say the meter is a separately derived system, but really, I don't know. I mean, it's the separately derived systems at the utility.
You can't do that because the code doesn't cover utility.
Well, he's saying the meter is a separately derived system. So, I mean, I guess you're not.
For the utility.
It's, yeah, I mean,
until
I don't know.
Think of it this way. Until you establish that first point where your overcurrent protection is, everything is considered what? Supply side, isn't it?
Yeah. Period. So here in Colorado, our main disconnect is our first means of disconnect. That's our service entrance. Basically, anything on the other side of that's not covered, even though we do run the cable. Like we do pull conductors to the meter. So we'll pull conductors on the line side, and then the utility will hook to them. But
I'll bring up one more point. We have a place, one of the counties here in Texas, and one of the things they started doing is they provided overcurrent protection right at the meter base, and they specifically called and the way our state inspectors looked at, if I take and I have overcurrent protection there, guess what? That was my first disconnecting means. And from that point, when they went into the panel, guess what? That neutral was isolated.
Right. Yeah, so it looks like Justin's agreeing with you.
Oh, we've had a lot of discussion, and I think the wording needs to be cleaned up a little bit in 230.85. That's my opinion on it, because
I agree.
Even Justin's old school like me. Justin and I grew up with the same concept. Once you establish that overcurrent protection, everything else on that's on the load side. He agreed with that. It's the wording, the way it's worded, that I don't agree with. And,
Right.
I look at everything from other type of installations too, and you're going to do it over here, but here you're not. I mean, we got to have a consensus. And I've always said the code should always have a consensus on the way that it applies for each installation.
Dude,
Yes, it is, Dave.
Sounds like Andrew's asking if you got your bandwagon gear on.
You wasn't here at the first. I said, I want to get through this as soon as possible because I want to watch the draft. The Cowboys will be getting close to picking by then. All right, since we're at, let me get to my topic of the week.
All right, do it.
Oh, let me do my little intro for it. All right. Now, for the topic of the week, I was supposed to do this last week, but we had a storm here and we had the internet just completely knocked out. Now,
hey, James, I don't mean to interrupt you like the storm did, but Andrew says maybe next year. And I was going to tell Andrew that's why you have to go watch the draft.
yeah, baby. I don't know why I like the draft. I can tell you, I'm leaving here and I'm going up to meet the guys, and I'm going up to Hooters to have a couple of beers and watch the draft. So hopefully the Cowboys ain't picked by then. But
right.
I'm going to give everybody a rule of thumb here when you're looking at size and taps. This is very simple. If you take any tap and you divide by 10, or for 10 foot or less, you divide by 10. All right. Now, the thing that I want to point out here, every other tap, guess what you take it at? A third. Anything longer than that, you take it a third. There's only one variable to this. If I have a transformer in the tap, I've got to get the ratio of the secondary on the secondary side. But the primary, I still take it a third, and then I take the secondary to third plus the ratio of the transformer.
Right.
Now, when I did this was somebody was asking me how to do taps when I was on NEC Live, and I just made up a few problems and showed them how to go about doing the tap. And even Derek, he goes, I've never heard it explained that way. I said, you can go through and read every bit of this. What you're going to find out that you're going to take everything at 10 foot or less, divide by 10, everything else is at a third. And if you take and have a transformer tap, you do the ratio for the secondary side, and I'm going to show all that. Okay. Now,
dude, there was a certain individual after that just could not let the whole thing go. And what it turned out being was it was a 1500 amp bus section. And they're like, yeah, they want to take number 8s off that 1500 amp bus section, go to 60 amp disconnect, then go to a piece of equipment. And I was like, okay, well, let's see what James has to say about it. And I think we brought it up to you on NEC Live. Then you're like, oh, yeah, it was like a number 4, I think.
Yeah, I showed how to do that.
As long as it was a number 4 to that 60 amp disconnect, you're good to go. I was like, what? That blew me away. Like when I saw that, I was like, oh. And then I think it had to be like a 1-out if it was like 25 foot.
Yeah. What was funny is I was explaining all that, and Derek, that's when they were trying to really promote NEC Live. I'm sorry, NFPA Link. And Derek told me, he goes, slow down. He goes, we can't keep up with you in all these sections.
Oh, yeah, I remember that. Yeah, they were trying to go on the link and show everyone the sections and everything.
What was funny is I was already explaining what the section said, and they finally get over and it's almost word for word. He was like, I don't know how you remember all that crap. But
dude, telling you, the stall cups are legendary.
If you look here at 4, as I'm looking at 240.21B1 here, it tells you here that I'm going to take it at not less than what? 1/10. So that's why I say divide by 10. All right. Now, as you look at this, I've got a 600 main upstream, 10 foot or less. I'm going to divide by 10. That gives me 60 amps. And guess what? I need to go look at table 310.16. And when you go over there, the next size above that is 65 amps, which is a number 6. So I have to have at least a number 6 going down to that on that from the tap down to that panel board. I have to have at least a number 6 conductor.
But you have 2 overcurrent devices, so is that a feeder? No,
now,
I'm just kidding. I'm just
yeah. Now, yeah, no kidding. Now, if you look at it, that's a feeder going across. And why is that a feeder? Because it's going feeding 2 or more objects. You see that?
I agree.
I mean, we're there. And I'm going to tell you, these illustrations, they're fantastic what's coming out.
Yeah.
I mean, these look, I mean, I haven't seen any illustrations look this good. But
yeah.
Now, if I look at that and I'm looking at sizing the overcurrent protection device, I can take, and let's say I protected the load's 60 amps, I could put a 60 amp on there, or I could take and protect the conductor and go up to what? 70 amps, and you can pick that information up over in 240.4B. Okay. And you remember I did a thing on how to go about looking sizing overcurrent devices, and I talked about how sometimes 240.4B, when you look at table 310.16, the overcurrent device and the conductor don't match up, but it gives you the option to go down to protect the load or protect the conductor.
Okay? Yeah, and that was one thing I would have never even known until you did that series. But it says either or. It doesn't say must be, you know. So
that's right.
That's pretty funny that you brought that up. And it's anytime people go like you know what the code's made up of? Shalls and shall nots. You know, shall be permitted, shall not be permitted. You know, you just have to know how to interpret it. So I saw this bumper sticker. I saw this sticker on the way home, and I thought about this a lot. And I think about this about the code. So it says the Constitution of the United States of America doesn't have to be rewritten. It has to be reread. And that's the same way I feel about the National Electrical Code. It doesn't need to be rewritten. It needs to be reread and the way that it was originally intended.
Right.
So for these guys to come in here and say, oh, if you guys don't believe that's an outlet, then you're a bunch of hacks and you need to go back to school and learn how to read and all this stuff. It's like, dude, it doesn't say that box above that panel is an outlet.
Right.
That's ridiculous. It's a point on the wiring system that connects utilization equipment, you know. like it ticks all the boxes, you know.
That sucks.
Yeah, thanks, Andrew. I appreciate you, brother. Andrew's got my back, man. Right on. I appreciate it.
Dang, Falcons took Bijan Robinson. I was hoping he'd follow the Cowboys. Dang it. He was picked number 8. Oh, well. All right. Be interesting to see who they get next. All right. Now, as you look at B2, these are taps over 10 foot up to 25 foot. And if you look right there in B2-1, it says those tap conductors are not less than what? 1/3. Okay. Now, you can read all this other stuff, but I'm just trying to show the calculation. So I'm looking at this. I have to take it at 1/3. All right. So if I look at this, you're going to see we're doing a 600 amp again. I take it at 1/3. That's going to give me 200 amps. I go over and I look at table 310.16. A 3/0's good for 200 amps on the 75-degree C terminals. You just saw it too. Yeah. Bijan's going to be a stud, I think. But anyway, if you look at that, as I was saying, anything 10 foot or less, divide by 10. Everything else, I take it what? 1/3. Okay. Here you go. These are the rules. You got a 3/0 conductor. In that case, that means 3/0 is the smallest conductor, and I'd have to have a 200 amp overcurrent device there. Okay. Now, let's look. Here's where I deal with taps that I have a transformer that's inside that tap. And if you look at the B31, it says to take it at what? 1/3. Okay. And then if I look at B2, it says the conductor supplied by the secondary. Okay, the primary is a third, secondary. It says shall have an ampacity not less than the value of the primary to secondary voltage ratio that's multiplied by what? A third. Okay, so as I said earlier, everything else is taken at a third, but if I have a transformer in the tap, I've got to get the ratio of the transformer plus take it at a third, and the primary's taken at a third. Okay,
Wow.
so here's an illustration. I've got a 300 amp overcurrent device upstream. Take it at a third, gives you 100 amps. I go over and look at table 310.16. I need a number 1. Now, look at this. When I get
should we just start a new thing where we say how many outlets are in the picture?
Yeah, no kidding. All right, now look at this. If you take that secondary, I've got a 408 volt primary, 208 volt secondary. I'll get the ratio of that. It's like 1.2683754, something like that. And take that at a third, and then take the 300 amps that's upstream. That's going to give you 231 amps, which is going to require a 350 kc mil aluminum. And we did this on purpose. If you notice on the secondary, when you're looking at this, because this comes from the journeyman, so we're always trying to make you think of how you're going to go about doing calculations. We threw a little trick in there this time, and we put aluminum conductors there. So now you've got to look over to the next. Let's see, that'd be 1, 2, 3, the 5th column over in the 75° C column, and then you know you need at least aluminum conductor that's 350 kc mil. Okay, but
nice.
These are the things, and I tell people, if you actually take and you go through our journeyman program and you go through, this is what you're going to do. Now, what's interesting about this online, once I come out with all these new illustrations and everything, everywhere you're seeing I have these values in here, all you got to do is just click that value and input the information. Then you can work the problem. Now, one of the things that I've been hearing that a lot of people are excited about is you could be an inspector, contractor, journeyman on job, master, whatever. You can actually have access to the calculation program. Once you buy it, you've got it from then on. But if you're out on the job and you can't remember how to do all the calculation and where the sections come from, you can actually pull this up and you can put your own values in and work the problem.
Nice.
Now, one of the cool things is you can't see it in this because it's just the illustration, but once it's in full form on the left-hand side, I'll also have an NEC loop that takes you down to exactly by those steps through the sections you need to look at in order to do that calculation and see the information step by step so you know how to do it properly.
Nice.
Okay? Now, let's look at the next one. This is a tap over 25 foot up to 100 foot. I can read all these rules that are in here for you to look at and all that, what you need to do. But the main point is, since we're sizing the tap, let's see what it says here. I'm sorry, I didn't mean to touch that. If I take and look at this, it tells you in B43, it says the ampacity of the tap conductors is not less than what? A third. Looky there. I didn't change anything. So far, my rule of thumb is holding up. All right.
Yeah.
So
I haven't seen a rule of thumb come from you that didn't work.
Well, James Coburn, thou shalt let. Yeah, no kidding. Now, what is interesting is, Dad and I have between us about 80 years experience, maybe even more than that. But through all the courses that we've done, and we've been to a lot of big companies. I was instructor for 20 something years for NFPA. I've been to NASA, all the Department of Energy and Defense locations. I've been to DuPont. I just sat here and go on and on all these places I've been. And one of the things that happens is going to all these places, you get a lot of variables in the way people think. So it's one thing you can be talking to an apprentice, a journeyman, a master, a contractor, an inspector, engineer, maintenance personnel. Everybody has different thoughts in the way they look at it, and you start picking up things over time, and that's how we develop our style of training, so it makes it easier for everybody to understand exactly what you're looking for. So
yeah, and experience, to me, it's like in the automotive world, everyone says there's no replacement for cubic displacement. That's the same thing what I say in the electrical world. There's no replacement for experience in the trade.
there's not. Now, if I look at this is 25 foot up to 100 foot. I've got a 400 amp overcurrent device upstream. I take it at a third. That's 133.3 amps. The next size above, that's 150 amps. We're doing copper conductors here. And that would be a 1-aught conductor. That's how simple it is.
Right.
So basically, you don't have a 140 amp overcurrent device. So basically, you would go up to a 150 amp overcurrent device in this case.
Hey, I got a good one for you, James.
What's that?
Hey, if I have a question, I'm asking y'all.
Go
Don't
ahead.
ask y'all, ask James.
Hey, he said y'all. That meant me. If it's got y'all in it. That's funny. I like that. Good one, brother. All right. Now, let's look at if I was going to do a motor circuit tap. Now, it's going to tell you they shall be permitted to protect against overcurrents in accordance with 430.28 and 430.53 respectively. But since it's a tap, I have to apply the rules in what? 240.21b, because it's a tap. Okay. So if I have a tap that's 10 foot or less, what do I divide by?
10%.
If it was 10 to 25, I take it at a third. Okay.
Yep.
So, and a lot of people will get confused. They'll think, oh God, there's a motor in it. This ain't a regular tap. Yes, it's still the same tap. The upstream overcurrent device in this case, we say it's an 800 amp overcurrent device divided by 10. That gives you 80 amps. So therefore, you'd need if you go to table 310.16, the next size above that is 85 amps, which requires a number 4 conductor. So I could take and put, I'd have a number 4 conductor coming down. And then if I've got non-fusible or say I got time delay fuses in there, then those time delay fuses would need to be 80 or 90 amp, but it may have to go up to 90 to allow for the motor to start, wouldn't it?
Well, I just want to know where the feeder conductors are in that whole illustration, because, you have like the branch circuit conductors could carry through all that as long as you don't have fuses.
Yeah, well, the feeder is because it's going through feeding other 2 or more loads, like I was saying earlier. And then everything down from that point's a branch circuit. But in this case, you're sizing it as a tap. So you got to know what is the minimum size those tap conductors can be. And then you're looking at the size overcurrent device minimum there. But you need to also take and do the calculation for that 50 horse. And I'll give you an example. I can tell you that's the minimum size that's required, but that size is going to be larger. And I'll explain to you why. Well, I don't know, that might be pretty close to, that number 4 is going to work perfect. Let me give you an example.
Andrew, just to answer Andrew, basically the reason you do time delay fuses is because when that motor's starting, you're getting a high ramp of inrush, and you want that inverse time so that that motor has enough time to start. You're basically arc welding for a few split seconds.
Yeah, let me go on that. You said inverse time. So we'll say we do an inverse time circuit breaker. If I look at that motor, that's a 50 horsepower, 460 volt, 3-phase design B motor, and I'm going to size my inverse time circuit breaker. If I go and look at 430.6A1, it tells me to get that. Whenever I'm sizing the conductors or overcurrent device, to use the tables in 430.247 through 250. Well, since this is a 3-phase, I'm going to use table 430.250, and that 50 horsepower at 460 volts is going to give me 65 amps. If I take and go back and look at in the 2023, it'll now be 430.52C1, and it says in accordance with table 430.52C1 in the heading, and it says it shall not exceed the calculated load. Well, if I go over there and look at that table, it's going to tell me for an inverse time circuit breaker squirrel cage that I got to take that at 250%. Well, if I take that 65 amps at 250%, that's going to give me 162.5 amps. So therefore, I'm going to be looking at the size for that overcurrent device to be at least 150 amps. But now when I look at sizing for this motor, the conductors coming down, I've got to make sure that this is the minimum, but I got to make sure what size I need for that motor. So if I go look at 430.22 for a single motor, I'm going to take that 65 amps at 125%. That's going to give you roughly 81.25 amps, which a number 4 would be the exact size that was needed for that tap. And that pretty much is how easy taps are. I hope everybody enjoyed that. That was a lot of information to digest tonight, but I covered a lot of stuff, man. But I think it really showed what you needed to know when it comes to doing taps. It's not that hard. I can't hear you, Bill. You went off. Can't hear you. Thank you, man. I appreciate that. I really do. Can't hear you, Bill. Oh, you're clicked off here. Let me unmute you. Unmute your mic.
Oh, sorry.
There you go.
Yeah. I was here the whole time. I just didn't want anybody to hear my dog barking.
Oh, no worries. But
no, awesome to have you show up, Ruben. Yeah. We really appreciate having guys like you, Ruben. Really awesome to have you come in, and we're just trying to kind of push the whole thing. You know what I mean? Like a lot of these guys just try to stay with this residential stuff, and we're just trying to keep it real. Whatever.
You ready for your tool?
Let's do it.
All right, you got your tool of the week.
It's time for Tool Review of the Week. Sponsored by Electricians Only Tool Review and Nipex Tradesman.
All right, well, I was going to do this tool last week, and I kind of stopped in the middle of it. This is something one of my neighbors, we had a few branches fall on my garage, and we had like a bunch of wind and stuff, and one of my neighbors let me use it, and I was really impressed. It worked really good. I didn't see a lick of problem with it. Like I say, I used actually my own battery because he's like, hey, you got a battery? I was like, yeah. So I went and grabbed my 60-volt max DeWalt battery, put it on there, and it just cut through all the limbs really quick and got it all knocked out. So it's pretty sweet. Like I say, I'd recommend it. I didn't see a lick of problem with it. It seemed like we're getting to the point where we're starting to use a lot more electric tools now, and like I say, I would choose it 1,000 times over between trying to put gas and oil and everything in. Like I say, I just put the battery in, knocked it out, piece of cake, real easy tool to use. I really like the XR series from DeWalt, and would recommend to a friend. So yeah, my tool review on this was very good, user friendly. Put the battery in, knocked it out, and cut it all up, and called it a day. So
awesome.
That was an easy day Saturday for me.
Easy day Saturday.
Yes, sir.
I like that. Easy day Saturday.
Hey, so one thing I just want to let everyone know, I'm always trying to get James on the code question of the week. So like at the end of every show, what we try to do is we try to get James on a code question. So here we go. Code question of the week.
Hold on one second. Somebody sent me a message. How to calculate voltage drop. Okay. The way you're going to do voltage drop, there's a couple different ways, but I'm going to do the most popular way. The formula you're going to use is 2 times R times L times I divided by 1,000. Okay. Now, what that is, 2 is a constant. L is going to be your length. So whatever the length is, then you got your amperage. You're going to put your amperage in there, and then you're going to do the resistance. And you're going to go to Chapter 9, Table 8 to get the resistance of that conductor. You're going to multiply all that together, divide by 1,000, and that's going to give you your voltage drop. Now, depending on how you set it up, this is how most people do it. For the branch circuit, if you're doing a branch circuit, we usually do that at 3% or less. And then if you have a long feeder also, then you're going to do it at 2%, and you don't ever want to exceed over 5% overall. Okay, so hopefully that helps out. I don't remember exactly, but we did a topic of the week where I went through all the different voltage drops and everything and showed how to do it. I think I even showed how to do it for the fire pump, didn't I?
Dude, did I tell you we ran across the craziest voltage drop? So we're trying to ring out a circuit, and we got to a point where we were too far out in the circuit. We couldn't ring it anymore.
Oh,
and
really?
They actually said in the thing that a fluke meter can only ring up to 10,000 foot.
No, I can see that. Yeah.
So
I didn't know that, but yeah.
So we ran across it today. I was like, what? I never even knew that, but we figured it out.
That's interesting. I did not know that.
Yeah, we came across that.
Just to show, that's why we do this, because you learn different things. That's it, sure.
Yeah, and
it doesn't have any. No, that's the conductor. I'll give you an example. You've got to take and look at 240.22 also for the ground and neutral conductor, and you need to look at 250.122 for your equipment grounding conductor, because once you start getting in those lengths, you got to make sure that your conductors are large enough, just not the phase conductors. Okay, that has nothing to do with the disconnect rating it's over. You're just trying to make sure the conductor's large enough to take care of that load due to the voltage drop. Okay.
Well, so every week I try to surprise you, James, and so we have the code question of the week, and I think we have some winners this week, and
let's look at who your winners are. There we go.
There you go.
Okay, let's look at your code question this week. Let's see what you got.
Dude, I'm going to get you. I'm getting you this week, man. Dude, I got ChatGTP on this one.
You know what's great about this one? I just got through updating the transformer section. Transformer less than 1,000 volts and blank kVA is permitted to be installed. Oh, a hall space, that's easy. That's C, 50 kVA. I don't even have. I know it's right. You don't even have to tell me it's right. I know what it is.
Nailed it. Dude, ChatGTP said it was 37.5.
Nope.
Then I said you're wrong, and then it said no, it's less than 37.5.
Isn't that in section? I think it's like 450 30B or 31B. I think it's 250.
Close.
30B.
450.13B.
13B. Okay.
Yep.
I think
congratulations.
I think that was in another section before they rearranged some of Article 450 quite a few years ago.
Congratulations to all the winners. All the winners actually put the code reference in there. So I think that's awesome that we can throw these code questions up there, and everyone could find them real quick, throw the code reference up there. It's been a lot of fun, and you are profession.
You are profession.
All my buddies will get that one.
I know. I get it. That's pretty awesome. That's a good show. I enjoyed doing it this week.
Awesome, man.
Now it's time to get ready because the Cowboys are going to be drafting pretty soon. I need to go get some wings and some beer.
Yeah, dude, awesome for everyone hanging out for us. For such a long time. It was a really good time. We usually try to keep these around like an hour and a half. But like I say, when James has to do 3 myths of the week, then you know what it is. And
it'll take some time.
The whole reason we do this, you guys make the show. You know what I mean? It's really awesome. So appreciate you, Justin. That was awesome. Justin's big star this week. Really awesome to have him in here, and he always brings us value and insight to our myths and bring them to light. And you know what? You really did a good job, James. You kind of bailed me out from last week. I tried to field a few of the arguments and stuff, but I was a little bit lost because I just didn't have all the code references in my head like you do. So it's pretty awesome. Amazing to have you. And thank you for having me and, just ask stupid questions for 2 hours straight. So
no question awesome. Is a stupid question.
Yeah. It's only a stupid mistake. Mistake is the worst.
It's one. Only if you already done it that it is.
True. I always hate when I look at it and I'm like, dude, I did that wrong, didn't I? But it's a lot of fun, and we're all human, and it's a lot of fun doing this. And like I say, ACs are not outlets.
Oh God. I love this show. So much fun. Hey, I got something for you. Your Stars better kick it in gear, brother. They're down 3-2.
Yeah, true.
You saw the Stars took care of business. They're going to take care of business Friday. They're moving on. Y'all better get it together. Y'all want to play us.
We'll see. I mean,
I was at the pool hall when the Stars were playing, and they were up like 3-0, and then they got 4. I was like, it's done. They're just have one more, but man, they played that. You know what amazes me? I don't see how they see that damn puck. Man, that thing's moving so fast, and they're all jumping up. Oh, we scored, and I'm like, how the hell you scored? I didn't even see it.
The amazing thing to me is when they raise their stick up and they just tip it.
Yeah.
Like out of midair, and then the goalie's like, I didn't even see it, and it's like the goalie's sitting there with his glove up and then it just goes right under his glove. Like that to me just blows me away. I'm like, okay, it's like he didn't even see it. But we got McCarr back. We got McCarr back for game 6. So they were calling McCarr the dirtiest player in the NHL, the Kraken, and to me, that's the stupidest thing. It was just a little mistake. He was going hard on the guy. The puck went past. He hit him, and he got hurt. And next thing you know, McCarr's the dirtiest player in the NHL. It was so stupid. It irritated me a lot. I got mad a lot about it. He got suspended for 1 game. So we didn't have McCarr. It was like our 5th loss without McCarr since we've had McCarr. But, like I say, we're going to have McCarr back, and so I think it's going to give us a boost. We got to have McCarr, McKinnon, and I say we easily take Game 6 in Seattle and bring it back for Game 7 here in Denver. That's my prediction. You heard it here first.
I tell you, I guess playoff hockey is different than regular seasons because, man, I tell you, them guys out there are knocking the hell out of everybody. I like, dang. Yep.
100% agree, sir.
All right, let's wrap it up. I got to go get a beer and get some wings.
Remember, make every day an easy day.
Amen.
Peace out.
Everybody, have a good week. We'll see y'all next week.